Hi everyone and welcome to our webinar. My name is Nicola Accialini and I'm the CEO and founder of Accialini Training Consulting, and I'm very pleased to introduce you today to the Smart Factory. So before we start, just some basic information. The explanation, the webinar will last about 30-40 minutes plus 10 minutes of question and answer session. To submit your questions, you can use the chat you have on the Zoom bar. So you can just write down your questions, and at the end I will try to answer them. After the webinar, you will find the record, and I will send you the link also to the PDF documentation. So let's start, but before, some information about me for people who don't know me yet. My name is Nicola Accialini, as I said. I was born in Italy. I lived in Germany for about 4 years, but now I'm living in Spain. I have a master's degree in aerospace engineering. My work experience, I spent 12 years in the aerospace business managing manufacturing projects, uh, about 10 years in managing new product development projects, always in manufacturing, and 4 years spent in the development of an assembly facility based on 4.0 principle in Germany. The first thing is, what is a smart factory? What's the definition of a smart factory? Well, of course, a smart factory is a combination of two words. The first word is factory. So we are talking about factories, but the second word is smart. Smart means something related with the digital or intelligence in general. Can be human intelligence or digital intelligence. Therefore, the combination of a smart and factory creates the concept of a smart factory. But more in detail, sorry, I'm just updating people. Welcome to people who just joined now. I started 5 minutes ago, so we are very at the beginning of our webinar. However, I will send you the link of the recording of this webinar. You can find it on YouTube in a couple of hours. And I will send you a PDF documentation of the presentation I'm presenting now. So I was introducing the concept of smart factory, the definition of a smart factory. So the best definition of a smart factory is the following. So the smart factory is a production system which is able to facilitate the launch of new products based on market dynamics. It's scalable enough to meet the variation in the demand for existing products. Is able to produce finished product at minimal costs. Has intelligent machines, sensors, and robots that integrates perfectly with the IT system. And last but not least, I think for me it is the most important point, has real-time analytics that helps to minimize downtime and improve efficiency. So this is the best definition, a quick and short definition of smart factory. So next question is, why do we need a smart factory? Well, the point is that the smart factory is the final goal of Industry 4.0. And Industry 4.0 is a principle developed in Germany and became public at the Hannover Messe in 2011. With the goal to face and to support the manufacturing industry that was hit deeply from the crisis in 2006. So the first goal of a smart factory is to boost productivity following the 2006 crisis. But also, the goal is to cancel benefits caused from relocation or offshoring, Of course, with the globalization, Western countries moved their manufacturing companies in low-wage countries. Can be in Eastern Europe, can be in Asia, like India, China, Pakistan, Philippines. And for example, American companies moved their factories in Mexico, so in places where the labor cost is very low. The goal of Industry 4.0 and therefore a smart factory is to bring back the manufacturing in our own country, because with Industry 4.0 introducing new technologies is going to reduce costs, production costs. So the goal is reshoring, as I said, and also boost competitiveness, which means with Industry 4.0, with the smart factory, we are going to increase quality, reduce costs, and also at the same time reduce delivery time. And this is also for me the most important part is one-to-one customization. So flexibility in product variations, which started, we will see in the next slide, started with the third industrial revolution. So the idea is that to customize product as much as possible. Here, for example, in this chart, you can see the manufacturing output in the top 8 countries from 1970 to 2009. As we can see, the curve for China is growing exponentially, and all other curves from other main countries is increasing slightly. But starting from 2006, 2007 or 8, the manufacturing output started to decrease. Is evident, for example, in Japan, but it's very evident in Germany. So this is why the German government decided to launch this initiative in Germany. So as I said before, what are the 4 industrial revolutions? So if I'm sure you saw this chart already, but I think it's important to explain it from a production system perspective. So starting from 1760 and ending about in 1850, we have the first industrial revolution, which was allowed by the increase of trades and invention of steam engine and also development of steel manufacturing processes. So this period is characterized by low volume standardization. Next step, so the second industrial revolution started about historically in 1817 and ended just before the First World War, 1914, and is characterized by high volume standardization. So in this period, Henry Ford developed the assembly line based on the Taylor principles, which allowed high volumes of, for example, in the automotive industry, high volumes, higher efficiency, and at the same time using the scale economy, reducing costs. But the problem here is that the product variation was very limited. It's famous a sentence, a statement from Henry Ford, who said, "You can have any car, a car of any color you want. The important is only black. The important that the car is black." So, for example, the painting was not flexible, and the production system was not fixable, was super standard. Things changed starting after the Second World War in 1960s and continue up to 1990s, more or less, where flexibility increased because of 2 main factors. The first factor is the introduction of the Toyota production system, which with lean principle was able to reduce waste and to increase flexibility at the same time. And the second factor is the development of computers, which allowed enhance the industrial automation system. So with digitalization and automation, industrial robot substituted people, but keeping a high level of automation, so a high level of efficiency, but keeping the flexibility at a high level. So this period, this car is called a high volume customization. So what's next? Next is the fourth industrial revolution, which officially started in 2011, as I said, at Hannover Messe. So this is more an evolution from my point of view than a revolution, which means that the production system is characterized by one-to-one mass customization by exploiting new digital technologies, which means that the concept developed during the third industrial revolution will be used to will be used to increase the output, to increase the throughput, to increase quality, but keeping system even more flexible than before by, for example, Internet of Things, big data analytics, additive manufacturing, and other basic key technologies that we are going to explain in a few minutes. So if we think about the state of the art to date, there are already factories that are using Industry 4.0 principles, and we can already consider them as smart factories. One of them is what you can see now in the picture is the BMW plant in Munich. So the BMW plant in Munich is producing the M series. They are delivering 1,000 cars per day, which means, but with a high level of flexibility, and statistically only 2 models per month are the same. So if what's happening in this factory, if we are going to assess automation versus customization at BMW in Munich, we can identify 5 different main steps of production. So by the way, if you can attend visits, you can visit the BMW factory in Munich. They have you can just reserve your seats. I think the last time I was there was in November 2019, so November last year, and it's 2-hour tour, and it's very interesting for people who are interested in production system in new technologies. So during this tour, you are going through the main manufacturing steps, the main manufacturing steps of a BMW car. So the first manufacturing step is the press shop, where metal sheets are printed and then delivered to the body shop, where the cars are the sheets, the metal sheets are assembled, are welded, fully automated. The next step is the painting shop, where all cars are all the body frame are painted. Next step is the engine assembly, and then is the final assembly of the entire car. So there are these 5 main steps. But if we try to assess what's the level of automation and customization, we can see that at the very beginning, the level of automation is very high. Everything is printed in just fully automated. There are only few people for final inspection. They have samples and they inspect visually all parts. But the level of customization is very limited. I estimated about 5%. If we continue in in the process, we can see that the level of automation and customization is about the same. So high level of automation and low level of customization. Things start to change in the paint shop. So the paint shop, the level of automation is still very high, but the level of customization is higher than before. Why? So BMW developed a one-piece flow paint shop line where all cars, all models are painted in all different colors. So they don't produce by batch, they produce by one-piece flow, which means that all models you can find in the line, all different models, and all models can be painted in all very different color options. Then we go through the engine production and assembly. And here we can say that the level of automation is much lower than before because most of the operations are manual. And but the level of customization is still pretty, let's say, we can say like the paint shop, because there are different engine variations. There are no and so the variation, the engine variation is pretty high at the moment. But what is different is the final assembly. So the level of automation is higher than before, but much lower than the first three steps. On the other hand, the level of customization is very, very high. So in this line, the line is about 3 kilometers long, and all models are assembled in this unique line. As I said, only at the end, only 2 cars per month are statistically the same. So the level of customization is incredible. So what's the challenge at this point? We said that the level of automation is different at different stages of the process. So, but the goal is to achieve 100% of automation, and at the same time 100% of customization from the beginning for all processes. So this is the challenge, this is the goal of Industry 4.0 and of a smart factory. So how does a smart factory work? So if you ever work in a factory, we can, for example, identify different manufacturing steps like machining, can be then assembly or welding or painting. And then we have some manual operation like packaging, delivering, and so forth. So of course, the amount of manual operation in a smart factory will be limited, but will still be present because we can't get rid of workers, even though we'll be limited the workforce. So the idea is then to have a cloud or a central intelligence, which is going to manage the manufacturing process. So practically, let's start from the first process. We have a machining process, can be a lathe, can be a milling machine, can be a drilling machine. All informations, all the information from the machine status, machine health, or the measurement inside the machine of this part are sent to this central intelligence, which is going to elaborate this data in real time and will deliver feedbacks to the machine, so to adapt the machine to the current output. But also we deliver information to the downstream, so to the next operation, but also to other operation, in order to provide them information and to allow them to adapt according to the information we had at the first step. So next step, the part will be manufactured, will be worked in, for example, by a robot or for painting or for welding. And again, the information will be delivered to the central system, and the information will be then delivered upstream and downstream again. Then the part will be delivered to the final step, and again, the information will be delivered to the central intelligence, and then all the information will be delivered to the entire line. So all the information will be managed and analyzed in real time, and all data will be exchanged by sensors, by communication systems. So in this case, for example, we have a central intelligence, which is which used what we are calling big data analytics technology, and all information will be exchanged through our IT architecture, through cyber physical systems, which are using Internet of Things to exchange data, and to avoid that data will be stolen by third parties, by other companies. We need to implement a high level of cybersecurity. So these are just basic key technologies that will be developed in a smart factory. But of course, to design a smart factory, we can also use digital technologies. For example, a basic tool to use to develop a smart factory is called discrete event simulations. So this is in this picture you can see a screenshot from process simulate by Siemens. So the idea is to assess our manufacturing system in different blocks. And the output of this analysis would be to identify how many parts I can deliver per day, weekly, monthly, or yearly. What's my bottleneck? Where my bottlenecks are, and so the level of efficiency, the workforce efficiency, the machine efficiency. So a lot of metrics, a lot of parameters can be assessed in advance before we deliver or we buy new assets. Next step is, for example, to deliver a digital mockup. So nowadays, this is the standard when you develop a new manufacturing system. So you develop a 3D model of your assets, of your manufacturing, because compared to the traditional 2D models, 3D models are basically, they don't, nowadays, you don't need to spend much effort compared to the model, to the CADs, but they add additional information. So for example, you can assess easily ergonomics issues or how to allocate the resources easily, how to the envelope of each and of each asset. And also, for example, in case of robots, you can assess the cinematic or the dynamics of a robot. The final step before delivering a smart factory, the ideal is to use virtual reality. So in this picture, you can see a colleague of mine from the Manufacturing Technology Center in Coventry when I worked in Germany. So we worked with a research center in the UK. And before delivering our new facility, we create a 3D model, of course, but then we exploit virtual reality in a cave. So using cameras and screens and special glasses to assess a lot in much more detail, how the smart factory will look like. So ergonomics again, and all other factors that impacts heavily on a factory. So when we develop, so we said that the smart factory use different technologies, and then to develop a smart factory, we can use also other technologies. The final step to deliver a smart factory is to implement a digital twin. So the idea is once we develop the real factory, our physical asset, we study how to allocate the layout of a smart factory. We implement also the production system, and also we delivered a digital mockup. The idea of digital twin is to connect with the Internet of Things, the real world with the virtual world. So the real world will exchange data with the virtual world, and then the virtual world will analyze through artificial intelligence, machine learning, and so on and so forth, all data, and will give feedback to the real factory to allow the factory to adapt it autonomously. So the idea of a digital twin is to implement such an intelligence factory that we don't need to provide input to the factory, but the algorithm itself that we develop will allow the factory to adapt autonomously. So of course, what are the benefits in a smart factory? So everything started with simulations. So when we introduce simulation in a factory design, we are going to reduce risks and to prevent risks. We are going to optimize the processes, And we can also simulate different scenarios. So for example, if something happens, if workers can't come to work for a certain period of time, if there is a pandemic, for example, like what happens in these last months, how these scenarios impact on our factory. Well, if we have a simulation of our factory, the logic of our factory, we can simulate easily, and we can provide corrective action in real time. But of course, the final step, as we said, is a digital twin. But what is the benefit of a digital twin? So we can correlate simulation starting from real data. So we can use the real data coming from the real system to optimize the simulation and to give better feedback to the real factory. And so there is a typo here, a remote control. So in this lockdown period, a lot of people could work from home. So they applied what is called home office. But of course, we close the factory most of the time. Because we still need people to manage a setup, to manage a factory. But if we are able to create a digital twin, a digital factory with a very little amount of workforce, we will be able, in principle, to control our factory remotely. So we will be able, through Internet of Things, to data analysis, to say the asset in our factory, how to behave, what to do. So in this context, our role is going to change as well. So our role as engineer and process engineer, we are going to use tools, simulation tools, much more often in a production environment. So our goal as a process designer is to design flexible manufacturing system using digital technologies. But the role of workers operators is going to change as well, because it's more likely that they become more, they have different functions of monitoring and maintaining the system rather than doing physical activities in the shop floor. Of course, all these benefits, all these changes are not for free. There are a lot of challenges to develop a smart factory. And some of the main challenges are managing challenges, like companies should have a long-term vision. The main reason is that to develop a smart factories, we need to develop a high level of investment. So we need to investment, especially for old companies, in digital technologies, in developing IT architecture, implement cybersecurity, investing in new technologies, and the depreciation should be considered over 10 or 20 years to get benefits in terms of cost. So we need to have a long-term vision. We need to implement a change management, because it's very likely that we are going to approach the manufacturing system in a different way. So we should be able and ready to change. We are going to increase complexity, at least at the beginning. So we need to be ready to manage complexity properly. And of course, we need to manage innovation properly. And last, we need to start a reskilling process to reskill the management first, to reskill engineers, and to reskill workers to be able to use these new technologies. And there are, of course, on the other hand, other technical challenges. The first is to attract digital talents. Most of the technologies in a smart factory will be digital. So we need to attract digital talents. Of course, all information will be exchanged through Internet of Things. So we need to have a fast and reliable connection between cyber physical systems. Therefore, we need to develop a proper IT infrastructure. And of course, different sensors, different actuators are using different standards and different protocols. So the goal, one of the challenges is also to create a unique standard in order to collect the data properly and to analyze them properly. And as I said other times during this webinar, cybersecurity must be implemented in order that the probability to be hacked will be very, very low, because most of the information will travel through data. So what are the 4 main steps to develop a smart factory? Just to summarize, the first step is to develop, create our physical world, which means to implement a flexible manufacturing system. And to do that, we should use to develop the virtual world. So we are going to use digital software, digital system to support the physical world. But then we should be able to find a way to connect the physical and the real world. The virtual world. Sorry for the typo. And the next step, once the physical world and the virtual world is connected, we should be able to develop a digital twin to predict the future throughout real-time analysis. So in this slide, we are going just to have a quick overview. What are the 9 key technologies according to the Boston Consulting Group? So the 9 key technologies are additive manufacturing, Internet of Things, autonomous robots, which means collaborative robots and automated guided vehicles, big data analytics, simulation, augmented and virtual reality, horizontal and vertical IT integration, cybersecurity, and cloud computing. So, by the way, for people who didn't join since the beginning, we have a chat here. So we have like 10 minutes left. At the end of the webinar, we are going to we are going to have a question and answer session. So if you write down any questions you have now, I'm going to try to reply later. So where to start? So the first step is to train people in a factory, starting from the management, the senior management. So most of the barriers I'm seeing now is that people are not aware of what Industry 4.0 is, what a smart factory is. Most of the people think that a smart factory means that the machines are just connected to the server and they collect data together, but they don't know what to do with this data. They don't know how to manage data. They don't know that actually there are other technologies, as I said in the previous slide, to develop smart factories. They don't know how to apply in concrete additive manufacturing. They don't know how to apply virtual reality, augmented reality in the factory. So the first thing is to have training sessions at all levels of the organization. The second step is to have a benchmark. So to check, to research how, what's the benchmark level? So how other factories, how our competitors are approaching to the smart factories and to new technologies. One of the main, from my perspective, one of the best things to do is to attend trade fairs, to attend seminars about these topics, because you can find concrete applications on the field of new technologies. So one of the main concepts I would like to highlight is that we don't have to develop new technologies. There are a massive amount of companies that are offering, and worldwide, that are offering concrete and reliable solution to be implemented in our factory. The most difficult part is to identify what is the technology, the best technology to be implemented in our factory. And then once we started our training program and we identify what's the benchmark in the market, in our market, reference market, we should be able to start pilot projects. So we mentioned that the first step is training. My company, so Accialini Training Consulting, develop a smart factory masterclass that can be delivered in different formats. The traditional format is the face-to-face, so we can come to your factory, to your facility to start a training sessions. But of course, in this period where it's quite difficult to travel most of the time, another approach is to have virtual classes. So virtual classes is basically webinars and organized with the company on specific topics. We deliver massive open online courses, so e-learning platform. And in the next slide, I will show you our proprietary platforms called Skills4i, where we implemented these asynchronous learning courses. Or we can have a mix. So most of the time it's better to mix e-learning with virtual classes, or blended. We can mix face-to-face with virtual class and mock and e-learning or mock courses. So what is the program outline in this case? So basically we're going to define what the smart factory. We are going to explain more in detail what are the key technologies within a smart factory. We introduce the concept of Lean 4.0 because 4.0 technologies are synergic with lean manufacturing principles. We are going to provide you guidelines to design smart factories and to define what are the main skills and challenges to develop a smart factory. So this is the platform we have. It's called Skills4i. You can find it visiting skills4i.com. If you look at, this is the screenshot of our catalog. So in this platform, you can find different courses. We have about 9 courses implemented about Industry 4.0. But there are also a bundle product is called Industry 4.0 Training Program, where you can find all courses all together. There are 8 courses plus 1. So periodically we provide some discounts. So for example, the Industry 4.0 Training Program in total is for 40 hours course. And you can have more than 100 links. You can have text, you can find videos, you have after each lesson, we have quizzes, and after each course, you can achieve a certificate of achievement. But also what is very important for companies is that you can create your training groups. So the platform gives the possibility to create groups where a group leader is assigned, and the group leader has a dashboard where he can monitor the progress of each member of the group. So, and the good thing is that with this solution, people can progress the course on their own pace. So they don't have to dedicate a massive amount of time during their daily job at a certain period. But when they have some free time, like half an hour or 15 minutes, because most of the lesson and topics are divided into 15 or 30 minutes lesson, they can exploit this spare time they have to develop their skills. So if you have any questions now, I can give you, if you want, 5 minutes to think about some questions. So you can use, as I said, the chat that we have. You can find it the navigation bar, Zoom bar. Sometimes it's on the top, sometimes it's at the bottom of your screen. Okay, do you have a question? Thank you for the comment. Very nice summary. If you don't have question now, or if you will have questions at the end or another time, you can contact me at any time. These are my contacts, so you can contact me at info@accialiniconsulting.com by mobile phone. You can visit our webpage. And also, if you're interested in e-learning courses, asynchronous courses, you can visit skills4i.com. Or yes, if you have any questions in the future, please contact me for free. I will be happy to reply to answer your questions. So I'm thank you everyone for attending this webinar. In a couple of hours, I will send you the link where you can find the recording of this presentation, of this webinar. I can send you the link to download this presentation. And if you want to stay updated with future webinars, please go to accialiniconsulting.com, subscribe to our newsletter, or you can find additional information on our Facebook page or our LinkedIn page. So thanks you guys again, and I hope to see you again in future webinars. And goodbye, and have a nice week and a nice weekend.